Okay, let's start this with reviewing what we did in the last video. So what I want you to do with these three problems is to rewrite them in exponential form. So all of three of these, there's not going to be any solving to it like we did in the last problem. We're not solving for x. We're just taking this equation and rewriting it in exponential form. So a quick reminder, step 1, the base stays the same. Step 2, flip the input and output. So I want you to pause the video and try rewriting these in exponential form using those 2 steps from the last video. Ready, set, go. Welcome back. Check what you got with what I got. So for A, I got 4 cubed equals 64, which is true. For B, I got 5 to the negative 2 equals 1 over 25, which is also true. And then I got 65 to the 0 equals 1. So if you remember, anything to the 0 power will always equal 1. That's one of those rules of exponents that you've talked about in the past. Okay, let's go to the next page and try this one. So let's go the other direction now. This is written in exponential form. I want to change it to logarithmic form. So I'm going to take it from this to something like that. And the nice thing is, it's actually the same 2 steps. So step 1, the base stays the same. Check. Step 2, flip the input and the output. And you're done. That's it. So I want you to pause the video and try and do B and C. Ready, set, go. Let's see how you did. So for B, I got log base 10 of 1 over 100 equals negative 2. And C, I got log base 6 of 6 equals 1. Now, I want to use these 6 problems to introduce another idea to you. And that is these basic properties of logarithms. So we had mentioned that there was an exponential rule that anything to the 0 power will always equal 1. So, for example, I could take 8 to the 0 power and it's going to be 1. I could take 23 to the 0 power and it's going to be 1. I could take 136 to the 0 power and it's going to be 1. Always, always, always. Well, if I take all 3 of these and I change them into logarithmic form, I would get, this one would become log base 8 of 1 equals 0. This would be log base 23 of 1 equals 0. This would be log base 136 of 1 equals 0. Just like this was log base 65 of 1 equals 0. Are you starting to see a pattern? This is your first property of logarithms. And it's that no matter what the base is, if the number inside is a 1, your answer will always be 0. And it's because of this rules of exponent turned into logarithmic form. So if you go to the bottom of this page, you'll see that rule right here. No matter what the base is, if your answer is 1, or your inside number is 1, the answer will always be 0, every single time. So that is our first property of logarithm. Now I'm going to come over here to this one that we just did, and we're going to talk about another one. There's another rules of exponent that you've done where any number raised to the first power is itself. So any number raised to the first power is itself. And that rule always, always holds true. That's a rule of exponent. So let's do the same thing and turn these into logarithmic form and see if we notice any patterns. So this is going to be log base 8. and then I flip my input and output of 8 equals 1. This one, log base 9 is my base. Flip my input and output is 1. This one, log base 123, flip my input and output. Are you starting to see the pattern? Just like over here, we had log base 6 of 6 equals 1. Anytime the base and the input are the same number, your answer will always be 1. And you can see that right here on your second property of logarithm. If the base and the input are the same number, the answer is always a 1. Now, we have one last property of logarithms that I want to introduce to you. And we're going to do that using this problem right here. Now, this problem might look kind of weird at first. Let me make it a little smaller so I have some room to write. When you think about it, log base 10 of 1 over 100 equals negative 2? That's kind of strange. So let's try and pick this apart a little bit. Log base 10. What if instead of writing this as 1 over 100, I write it as 1 over 10 squared? Are we okay with that? 10 squared equals 100. We're good? Okay. Equals negative 2. Now, there is one other rule of exponent that we haven't talked about yet, but you should have talked about in past years, that says I can flip a fraction, and what's going to happen is the sign on my exponent will change. So instead of 1 over 10, I can write this as 10 over 1, but the sign on my exponent is going to change. So instead of a positive 2, it's going to change to a negative 2. And that's one of those rules of exponents. So if I rewrite this, I have log base 10. I don't really need the over 1. So this is what I've got. Well, do you notice where that negative 2 came from? You remember that when the base and the input are the same, the answer is 1. So they basically just kind of cancel each other out. And that's where we get our negative 2. So if the base and the input are the same, they essentially cancel each other out. And the exponent is our answer. That is our last property right here. If the base and the number inside are the same, they cancel each other out and are just left with the exponent. And we can go the other direction too. If we have a base and then a base here, they basically cancel each other out and our answer is just x. So here's what I want you to do now. In this next section, A, B, C, and D, you can solve all of these without a calculator, just using these 4 rules. So I want you to use those 4 rules, and you may need to use that as well to try and solve these 4 problems on your own. Pause the video and try that out now. Let's see how you did. So this first one, there's no base there, so we assume it's a secret 10. If anytime there's no base, we assume it's a 10. We talked about that in the first video for this lesson. And because that's a 10 and that's a 10, they basically cancel each other out, and we're left with the negative 4. This one, ln, we also talked about in the first video that ln is the same thing as log base e. So I'm going to rewrite ln as log base e. And then I have e and e, they'll cancel each other out, and I'm left with the 6. Log base 30 of 1, anytime the input is 1, the answer is always 0. Log base 50 of 50, anytime the base and the input match, the answer is 1. So that is it for properties of logarithms. In the next video, we'll do one more example of solving equations, of solving logarithmic equations that may show up on skill checks or tests.